Hello, let's continue from previous video. We start with some basic computer vision definition and algorithm. You can download the slides from this URL, and also you can download all source code from related topic from this URL. Just go through from previous session. We talked about artificial intelligence, machine learning, reinforcement learning, deep learning, transfer learning, computer vision, image, color space, image transformations, thresholding, histogram, image pyramid, type of image pyramid classification, motion estimation, optical flow, raster fine, and object detection. This object detection from the traditional computer vision, one of the famous methods for the object detection on that area is SIFT, but recently we have many different object detection based on the deep learning, video and image stabilization, and now let's continue. Video analytic goes to, okay, let's start with the camera calibration. Camera calibration is one of the main topic for the stereo vision and depth camera. Also, it has a lot of different area of the research for camera calibration. We want to calculate the intrinsic and extrinsic of a camera, which has a two matrix, and by using this tool, you can calculate the 3D point or remove some noise, distortion of the image. Very useful for this area. We have many different applications, 3D sense recognition, for example. We have a single camera calibration, a stereo camera calibration, and different kind of camera calibration we have. And this is the application. This is the noise and distortion of the image. You want to reduce this distortion. And this is the example of it. And also this is 3D reconstruction, depths, and measure the object. This is a useful application after camera calibration. As I mentioned before, we have extrinsic and intrinsic parameters for camera calibration. Location and orientation of the camera, intrinsic parameters inside camera, Here, a type of camera calibration. We have a self camera calibration, which is automatically. We have a camera calibration based on active vision, and we have a camera calibration with a known object. For example, like chessboard. Many researchers use that kind of calibration. This is a chessboard that's used in many different papers and applications for camera calibration. It's a simple chessboard, and based on the point, they use the size of each square and the point to doing the camera calibration process. Okay, this is the formula and source code from camera calibration in OpenCV. I put all source code on the GitLab. You can go and download the parameters, the translations, and other mathematical formula, evaluation. Okay, we go for pattern subtraction. These are methods in OpenCV. You can use any of them for pattern subtraction. We discuss about video analytic. For human robot and many robot application, SLAM is one of the great area of the research also, simultaneous localization and mapping. Then also this too is very important. For comparison, the two images, for example, you have a ground truth and you have output from your function. You want to compare the ground truth image between the output of your algorithm. So you can use the PSNR or SSIM to compare these two results. And in many papers, researchers use these two. Here's the PSNR. Active control also very important. Semantic segmentation I will discuss in deep learning part. Kalman filter is not computer vision, but good to be discussed. Reinforcement learning. Okay. When we have just one frame, we can do all these things: detection, classification, segmentation. When we have a different many frames, we can tracking, counting, and in the high level processing, we have a intention relation analysis for computer vision application. Image. And here when we have a image, video, and dynamic environment, the camera feeds, camera moving, object feeds always moving, and computer vision video analytic, the part that we use. Okay, for the next video, we go through deep learning and we discuss about the supervised reinforcement, unsupervised GANs, and all tools and the programming part. You can go through other videos inside the YouTube channel to see the code for each part of these topics.